The average household has many sources of sewer water. This water comes from everyday uses such as sinks, showers, and bathrooms. Water from these sources go down into the sewer pipes of your home that run into the ground. To many, what lies under the foundation of the average home is a mystery. Richmond is an old city, and one of the challenges of living in a historic city is the amount of underground obstructions. Examples of some of these obstructions may be cobblestones, left over from a time when horse and buggy was a normal mode of transportation. Others may be trash and debris, abandoned utility lines, rail remnants from Richmond's streetcar era, even old Civil War artifacts. Modern water lines and other utilities such as cable television, telephone, natural gas, and others also can serve as blockages. The existence of root systems are underground obstructions that can cause infrastructure damage to a host of underground utilities such as sewer and storm drain lines. The city is responsible for providing service that extends from the resident's property line and beyond. Residents may be surprised at the number of pipes that run under their property. Examples may include sump pumps, clean-out lines, which help your local utility clean out clogged or obstructed lines, storm lines, and sanitary sewer lines. Exterior water sources can include a variety of uses, from watering the lawn to washing the car. The average household can use several gallons of water daily. When multiplied over a neighborhood, this easily reaches in the upwards of millions of gallons per day. This water has to be managed efficiently and safely. The City of Richmond Department of Public Utilities has an intricate system of sanitary and storm pipes that aids in flood control and wastewater removal to improve the quality of your life. Storm drains assist in moving stormwater runoff from Richmond neighborhoods. Richmond weather encompasses a variety of rain patterns. Extreme weather, such as hurricanes, tornadoes, and severe thunderstorms, can bring large amounts of rain which can overwhelm the system when the precipitation falls within very short periods of time. During heavy rainfall, flooding can occur when water soaks into the ground, resulting in an abundance of groundwater and heavy infiltration. Inflow may also occur. This is the process of water seeping into the storm and sewer pipes. The James River is Richmond's major tributary, measuring 410 miles long. It is the 12th longest river in the United States that remains entirely within a single state. The 100-year floodplain shows us the area where flooding can occur if Richmond experiences a 100-year storm event. Engineers say that this is a storm that has the likelihood of occurring every 100 years. The city of Richmond developed a solution to address the issue of what to do with excessive stormwater. Unknown to many, this solution, known as Richmond's Combined Sewer Overflow Tunnel, exists almost totally underground and runs 1.3 miles and has a diameter of 14 feet. In addition, it has a capacity to hold up to 7 million gallons of water and serves as a temporary storage when necessary. The CSO tunnel is large enough to support the size of a tractor trailer. Flow regulators are an important part of the CSO system, directing flow through the collection system. There are three basic flow conditions for a regulator. Dry weather flow is the normal flow of wastewater that comes from your home and is transported to Richmond's wastewater treatment plant. Wet weather flow is the flow produced from average rainfall. Extreme wet weather flow is flow that produces large amounts of stormwater runoff that has a potential to overwhelm the system. The largest regulator is the Shako diversion structure. The function of a diversion structure is to receive incoming flow of storm and wastewater and distribute it to appropriate systems depending on the conditions. Beneath the diversion structure is a highly sophisticated system. The velocity reducers helps to slow the flow of incoming storm and sewer water and traps debris. The bascule gates manage flows during wet and extreme wet weather conditions. These gates, located beneath the ground, receive water from the box and arch sewer systems. A short tour through the arch sewer reveals the incoming flow, which is diverted to appropriate systems depending on the weather conditions. The CSO retention basin is an enormous system of channels. This rectangular-shaped basin is 1,200 feet long and 210 feet wide, about the size of a football field. It is 20 feet deep and has a capacity of 35 million gallons. Roller gates open to allow wet weather flow to enter the retention basin. As the water rises and fills the basin to its capacity, the roller gates close to prevent water from entering into the retention basin. As the water rises, the bascule gates open to release the flow to the outfall gates. The outfall consists of 5 flat gates that allow water to flow out of the system and keep the river from flowing into the collection system.